today we will look at trigonometric functions and equations using a word problem. So I suggest that you take a few seconds, you pause the video and you read the problem, take the time to try to understand what it is, and then come back with me and then we'll look at it together. All right, so when you read the problem, you have to find what are the most important information in the problem. And if you want, you can highlight the problem or write them down on a piece of paper, like the most important information. So here what I find is really important is that the tip of the long hand is going from 8:15 to 10 o'clock at night, and you want to find how long the tip of the long hand will be more than 210 centimeters away from the ground. So that is your question. What's important also that you know the length of the long hand is 15 centimeters, and they give you an information at 9:15 the tip is at 2 meters away from the ground. And so they're asking you what will the answer be of if you challenge finding this. So my proposition is that we try to graph to try to have an idea of what we're looking for. So if you were going to graph this, well, you need a y-axis and an x-axis. So on the y-axis, we're going to be looking at the height from the ground in centimeters. And on the x-axis, we're going to look at the time starting at 8:15. So from 8:15, and we're going to be counting in minutes. I think that's the easiest way to do it. Now the height from the ground is going to be, there's a 2 meters here that you have to be careful here. That 2 meters, you need to convert it in centimeters. So that's going to be 200 centimeters. And so when you look at your y-axis, we're not going to need all the numbers, so we can cut our axis. We're going to start at the bottom. Where is the bottom? So if you know that at 9:15, the tip is at 200 centimeters. When it's 9:15, where is the long hand? So think about 9:15. The long hand is here, so in the middle. So at 9:15, it's going to be at 200 centimeters. At the beginning, sorry, not at the beginning, at 9:15. So here you have 0, which is 8:15. And then we're going to be counting, I'm not sure, let's say by quarters. So after 1 hour at 9:15, our height will be 200 centimeters. All right, and then we need to find the time. 1, 2, 3, 4. Not until 10:15, because after 2 hours here, it would be 9:15. 10:15. We need one before that, so that's gonna be 1:05. That's where we're gonna stop. So actually, just to make sure we're not being confused, I'm just gonna erase that, and we're gonna stop at 1:05 because that's where we want to stop our problem. So what else do we know? Well, we know that it takes an hour for the long hand to go around. So if at 9:15 it's here, then 1 hour before it's also here. So I can draw this dot here. To help us graph, we should probably find our minimum and our maximum. So if in the middle here it's at 200 centimeters and the length of the long hand is 15 centimeters, then what is the minimum? You take your 200 and take away 15. So we know that the shortest is going to be at the shortest height is 185, and the maximum is going to be 250. So we know that in the first hour it's repeating. So if you remember, think about how does the clock work, right? It's going that way. So at the beginning, it's here. After 15 minutes, it's going to be at the minimum. So after 15 minutes, it's going to be at the minimum. After another 15 minutes, it's going to be back at 200. And then it's going to keep going to go all the way up here. And then coming back after an hour. And then it's going to repeat. So here it's going to go to the minimum. And then in the middle. And then on the top. So it's going to finish here on the top. So now take the time to sketch. Remember, it is not a line, so it's a curve coming down, going up, curve coming down, and going up, and then curve like this. And the question is, when is it going to be more than 210 centimeters? So where is 210 on your graph? So you can imagine if we're doing by 5, so 510, it's around here maybe. That's 210. And we want to find when it's going to be more than that. So we have to find here when it's more than that and here. So really what we have to find is these points here. And then after we can do intervals in between. If it helps you to understand better in your graph, you could also put the time underneath. So this is at the beginning at 8:15. This is at 9:15, so 1 hour after. And that's at the end of the observation at 10 o'clock. So I took maybe 5 minutes to graph this, but it's important because after that, all your calculation will be linked to that image, that picture that you have of the problem. So now keep that in mind, and then we're going to go into the calculation now. Actually, maybe on this we could write, so let's say we're looking at different points. Okay, so I'm going to be looking at this point. I'm going to call it x1. Okay, let's call this one x1, this one x2, and the next one x3. I'm going to be looking at these points. Let's see how we're going to find them. So to be able to find the rule, solving the equation, we need to find the equation first. So how do we find the equation of that sine function? So if you remember what the rule looks like, usually it's y equals a sine of b x minus h plus k. Now, where do we find all those parameters? So A is your amplitude. So you can find your A on your graph. Here is the amplitude. So it's really the length of your shorthand. So your A is equal to 15. B, so A is going to be 15. B is related to the period. So you have to remember that B is 2 pi over the period. Now in this case, the period is 60 because it takes 60 minutes to go over the clock. And so if you simplify that, 2 pi over 60, you can divide by 2 up and down, and you get pi over 30. So we have our B value. H is your starting point. Now you can see this, we could decide to take the starting point here. Then we would have a B of 30. But I suggest that we take the initial value here at 0 because then it's going to be a bit easier. Okay, so I'm just going to remove that. So I highlighted it so you can see our H. We're going to start at 0 and our K. Oh, but if we start at 0, you realize that our function is going down. So if it's going down, then it's going to be negative sign. So when we write our rule, we're going to write negative, or A is 15, so negative sign, or B is pi over 30. X minus 0, we don't need to write X minus 0, we're just going to write X. And our K, if you remember, K is the dotted line that's going in the middle. So in this case, our K is 200. So we have a rule. And we want to find the point at 210. I didn't write it on the graph, but we're looking at 210 here. What are the points when it's equal to 210? So let's put that equal to 210. That's what we want to find. Just this, I'm just gonna put it in the cloud so it's not in our way. Okay, so how do we solve this? Okay, so remember that first you should isolate this item here. So let's get rid of the 200, send it on the other side. And then after, this is negative 15 times sine. So we're going to divide by that on both sides. So we're going to have sine of pi over 30x is equal to 210 minus 200 is 10 over negative 15. Now this we can simplify. 10 divided by negative 15. If we divide by 5 up and down, divide by 5. So we are left with negative 2 over 3. So when is sine of an angle equals to negative 2 over 3? So imagine, think about your trig circle. Okay, and remember sine is the y value. So when is the y value equals to negative 2/3? It's about down here. So if we find our first angle, we're gonna have this. So we know we're gonna have two values, right? So we know that pi over 30x will be equal to sine negative 1 of negative 2/3. That's our first answer. And the second answer is pi over 30x is equal to, so if you look on your trig circle, the first angle we're gonna find is here. And the next one is pi minus, or sorry, yeah, pi minus our angle. So we're going to be able to find this one here. So if you write it here, pi minus your angle, sine negative 1 of negative 2/3. So if you take your calculator, make sure you are in rad. And then after, you need to divide by all of this, you need to divide by pi over 30 to get your x, to get rid of this. So you're going to find that x is equal to, well, it's not exactly, so I'm just going to remove that equal sign because you'll see it's approximately equal to negative 6.97. And the other one you find is, no, it's not equal, it's approximately equal to 36.97. So if you look on your graph, what is it that we found? The negative 6 is the one back here. We don't really need this one, right? We want to find x2, which is the next one after that. We're going to take negative 6.97 plus our period. Our period is 60. So we're going to add our period. And so we can find our value, which is going to be equal to about 53.03. 53.03. So this will find this one here, or x2. The other one we found, x is about 36.97. That's what I can call this one x1. If you look on the graph, we can see that's x1. And how do we find the next one? How do we find x3 here? X3 is going to be equal to 36.97 plus our period of 60. So you're going to find 96.93. Sorry for my writing, my mouse. 96.93. So now that we have our values, let's try to formulate what the answer is going to be. So if you write it as an interval, if you look at your graph, what it means really is from x1 to x2, and then from x3 to the n. So when you want to write it as an interval, it would look like this, from x1 to x2, and then from x3 to the n. But if you remember the question was how long the tip will be more than, so how long, what you have to do to figure it out is you have to find 53 minus 36 plus 105 minus 96.97. So the answer would really be, if you take your calculator, you keep two decimals, the answer would be approximately 24.09 minutes. Hope you had fun with this word problem, and keep practicing to make sure you get better. Bye.